Okay, so in today's lesson, we're going to do isosceles triangle properties. Just as a reminder, right, what is an isosceles triangle? By definition, it is a triangle with at least two sides congruent. We do refer to the two sides that are congruent as legs. All right, the legs then form the vertex angle. Right, the non-vertex angles are called base angles, and the side that isn't congruent is the base. This is important to know the different parts because we're going to encounter different theorems. So the first one we're going to encounter, actually the first two we're going to encounter, isosceles triangle base angles theorem. I know it's a long name. We can abbreviate it. So we can just say it's the isosceles triangle BAT, base angles theorem. And then we have the isosceles triangle vertex angle theorem. And we can abbreviate that one too. So that one's going to be isosceles triangle VAT. And the first one you're going to use a lot whenever you're solving for measures. This second one you're going to use a lot whenever we're doing proofs. Right? So the first one is probably going to be our big focus for today. And that's the base angles are always congruent in an isosceles triangle. And it works both ways. That's why we mentioned the converse here, is because you don't always have to see two sides equal in an isosceles triangle. You can actually just see two angles equal in a triangle. And that's enough to justify that it's isosceles as well, now that we have this theorem. So let's take a look at this first problem here. If I need to figure out what x is, right, we can verify right away that this is an isosceles triangle. The reason being, I've got two sides in a triangle equal. Well, that helps me try to figure out, right, so this is the vertex angle. What are my two base angles then? Mark them up right away. And I should mark those angles equal. So those two angles are equal, which then tells me, hey, 6x minus 1 equals 77 degrees. If this was a proof, the reason would be the isosceles triangle base angles theorem. And then I can just continue solving it. So add 1 to both sides. X equals 78. And then divide by 6. X turns out to be 13. Next example. So again, the same thing. I've got a triangle here. I know that it's isosceles because I have two markings telling me the two sides are equal. Now, what I need to do is identify what's the vertex angle, right? So the two sides that are equal tell me this is the vertex angle, which then tells me what's the base angles. Now, in this one, the unknown variable y is not in a base angle. So what I'm actually going to do here, right, is add up. I'm going to use the isosceles, or not the isosceles, I'm going to use the triangle sum theorem. So because I know this angle is also 65 by isosceles triangle base angle theorem, I can then do 65 plus 65 plus 3y plus 2. And again, the reason for that setup is triangle sum. There. Now I can clean this up. I get 130. Forgot to equals one. Have my equals 180 plus 3y plus 2 equals 180. I still got another term to combine. So 3y plus 132 equals 180. Subtract 132 from both sides. I end up with 3y equals 48. Divide by 3. Y turns out to be 16. Now this one doesn't deal with sides, so always make sure, or I'm sorry, this one doesn't deal with angles. How do I know? There's no degree signs around this expression, right? There's no parentheses, no degree sign. So this one is just simply saying, hey, these two sides have this expression. How can I figure out what x is? Well, if the two sides are marked congruent, right? Congruency implies equality. So then I can say 19 times x plus 3 equals 8 times x plus 14. And then I can solve, right? The reason for this one is simply the definition of an isosceles triangle. So the definition of an isosceles triangle lets me know that those two sides are equal. Or you could say given, because they are marked in the picture as it is. Subtract 8x from both sides gets me 11x plus 3 equals 14. Subtract 3 from both sides, 11x equals 11. X turns out to be 1. We get our third theorem here, and that's equilateral triangle theorem. So if a triangle is equilateral, then it's also equiangular. It can be really helpful for us when we're trying to solve for missing measures or sides. And that will complete our lesson for today. Thank you.